Okay, cool. Today I'm going to chat to you about AI models. You might be thinking, why should I care? Well, AI is becoming so deeply woven into everything around us that I think it's very important to understand the threads that hold it all together, that being AI models. Having a basic understanding of these models isn't just about keeping up with the latest trends in technology, but it's about empowering yourself with the knowledge you're going to need in an increasingly AI-driven world. These models are becoming the new software of our digital world. They're even starting to make decisions behind the scenes as to what job opportunities were shown when we're looking for jobs, what news were being shown, or even in some cases, whether or not we get approved for certain services, which is crazy. In many ways, AI models are becoming the new interface to our online worlds, shaping how we interact with technology and how technology interacts with us. So I wanted to make a video to break down this concept of AI models in a hopefully non-technical and easy to understand manner. First, we'll break down the basics of AI models, what they are, how they're trained, and the kinds of things that they can do. Next, we'll explore multimodal models. These are a type of AI that can combine different types of information. And then finally, we'll dive into the really big ones, foundational models. These are like the Swiss Army knives of AI. They're designed to handle a wide variety of tasks, and they're shaping what AI will be capable of in the future. In simple terms, an AI model is a complex algorithm trained to perform a specific task. To make this easier to picture, imagine an AI model as this cube. This is the AI model or container, the structure that houses our algorithm. The algorithm or brain of the AI learns from patterns in the data it's given, just like how people learn from experience. In this case, the specific task it will be trained for is generating and understanding text that mimics human language. At first, before it's trained for its specific task, the cube is clear. This is what's called the pre-trained state. The model already learned some general information from large data sets, but it hasn't been specialized for a specific task just yet. During training, streams of text are fed into the model, helping it recognize patterns in the text and understand how human language works. This process of learning turns our AI model into something called a large language model, which again is an AI model that's really good at understanding and generating text that sounds human. ChatGPT is an example of an LLM. It is powered by an AI model called GPT-4 as of the current iteration. Think of GPT-4 as the engine under the hood and ChatGPT as the dashboard you interact with. Once the model has been trained with all this data, it becomes specialized in performing a specific task. Again, in this scenario, generating and understanding human language. One super important thing to note is the quality and variety of the data used to train the model are super important. They determine how well the AI works and whether it has any biases. Now, this training process we've just gone over isn't unique to text-based models like LLMs. It's actually the same process used to train any AI model. The only thing that will differ is the type of data you use, whether it's text, images, or sounds. The basic idea stays the same. These different types of data are called modalities. So you're teaching the AI to recognize patterns, make predictions, or perform a task based on the modalities it's fed. So to wrap up, the training processes are the same, but the type of modality or data changes depending on what task the AI is supposed to do. Multimodal AI models are AI models that can be trained on multiple types of data. Traditionally, AI models were trained on a single type of data. These are called single modal models. But real-world problems rarely involve just one form of information, right? The world isn't one-dimensional. We live in a rich mix of sights, sounds, and language all working together, amongst other things, right? So to mirror this complexity, AI models can also be trained on multiple types of data. This makes their outputs and responses more versatile and accurate because they can draw from different sources of information at once, just like how we, as humans, process the world around us. In March of 2023, GPT-4 introduced multimodal capabilities to ChatGPT, allowing it to process images alongside text. By 2024, with updates like GPT-4, ChatGPT can now integrate voice, vision, and text in real time. Like now, you can have real-time voice conversations with these models, ask them to check out images and get detailed analysis, a bunch of really cool stuff. In 2025, it's even more turned. However, even multimodal models have their limitations. While they, yes, combine different types of data effectively, they are still designed for specific tasks only. These task-specific limitations raise an important question. What happens when a model needs to adapt to new data or entirely different challenges without being retrained from scratch? Well, that's where foundation models come in. Foundation models can be defined as AI models with general purpose capabilities adaptable for various tasks. For an AI model to make a real-world impact, it needs to be flexible and adaptable. It's kind of like an iPhone. It comes with basic pre-installed apps like messaging, a camera, a browser, a flashlight. Over time, you add apps and updates that allow it to do more. When you do that, you don't need to buy a new phone, right? You don't need to buy a new phone to install a new app or install a new software version. It's just the same device that becomes more useful and powerful with each new update and app that you install. This adaptability is made possible through transfer learning, the ability to apply knowledge learned from one task or domain and effectively transfer it to solve a new related problem with minimal additional training. This allows foundation models to be fine-tuned for new tasks, making them highly versatile and scalable across any industry, really. The really important thing here is that this removes the need to retrain an AI from scratch. Okay, so now that we understand what foundational models are, we also need to spend some time understanding how they come in different shapes and sizes and why. Whenever you'll see a foundation model being announced or discussed, you'll often hear or see terms like 7B, 13B, or 70B next to its name. These numbers refer to the size of the model in terms of its parameters, the parts of the model that allow it to learn from data. You can think of parameters as the neurons of the model, similar to how the brain works. Generally, the more parameters a model has, the more complexity and nuance it can handle, but also the more resources it will require. Computational resources. Why do these variants exist? Well, it's all about trade-offs. Smaller models like an 8B, for example, are built for efficiency. They handle quick, simple tasks, require less computational power, and can run on lower-end hardware like mobile devices. They're ideal for applications that don't need deep reasoning or large amounts of context. Larger models like a 405B one are built for more complex tasks, in-depth problem solving or generating detailed content. However, they do demand significant computational resources, powerful GPUs, and substantial memory. So for example, you'd have a small business that could use an 8B model for customer service, while a larger company could leverage a 70B or 175B model for tasks like real-time language translation. Now, you might be wondering, where are these models actually being used now? Well, these AI models can be plugged into just about any digital system or application you can imagine. They're the reason why that latest app you've just found on the App Store can transcribe your voice notes, generate creative artwork, summarize long articles in seconds, or even track your macros with a quick picture of your food. As these models continue to evolve, we'll see them powering even more innovative and surprising applications. So as you've seen, AI models are becoming the backbone of how we interact with technology, powering everything from tools we use daily to the decisions shaping our lives behind the scenes. Getting familiar with AI kind of feels like learning how to use a computer in the early 90s. It might seem niche or geeky now, but soon it's going to be an essential skill for anyone to learn. The more we understand these AI models, the better equipped we'll be to question, critique, and influence these systems that are shaping our future. Because ultimately, understanding these systems isn't just about keeping up with the latest technological trends. It's about maintaining autonomy in a world that's increasingly AI driven. All right, that's it for me today. Thanks for checking out the video. The end.